Hello, I'm getting quite a few queries by email about how to do the AC power questions of the quiz app, so I thought I'd do a few videos just to get you started. First, a quick recap on the theory. I won't go through why this theory works, this is just what you need to know to do the problems. We have this thing called complex power, usually write it as S, and the complex power is the 0 to peak phasor voltage multiplied by the 0 to peak phasor current complex conjugated divided by 2. For the reasons why that works, see either the lecture or the short introduction to AC phase. For now, that's just a formula that I will assume is true. Now, we also have from the AC extension of Ohm's law that the voltage phasor is equal to the current phasor times the complex impedance of a component. That's the voltage across the component and the current through the component, which has that complex impedance. We've also got the complex conjugate of that whole formula there, which is that the complex conjugate of V is equal to the complex conjugate of I times the complex conjugate of Z. We can then substitute in for the V or the I in this expression. And if I substitute in for the V first, I get an expression for the complex power, which is S times I Z times I complex conjugate divided by 2. That is equal to I times I complex conjugate times Z over 2. But anything multiplied by its complex conjugate is just the square of its magnitude. So I could write it like this. The complex power is the square of the magnitude of the current phasor through a component, or series of components, multiplied by the complex impedance of that component, or series of components, divided by 2. I could also substitute in for the complex conjugate of the current from this expression here, and that would give me S equals V times V complex conjugate divided by Z complex conjugate divided by 2, which is the square of the magnitude of the voltage divided by 2 times the complex impedance. Right. A few definitions of things. S, as I've mentioned, is known as the complex power. Complex power, if you're asked for that, that just means S, and you would be expected to provide both the magnitude and the phase of that complex power. Just write it as a complex number. The apparent power. The apparent power is the magnitude of S. It's called apparent power because it's what you would get if you just measured the voltage across a component with an AC voltmeter and then measured the current through the component with a AC ammeter, multiplied the two readings together and divided by 2. You wouldn't measure the phase when you did that, you'd just take the amplitudes of the two, multiply them together, divide by 2, you'd get that. We then got the active power. The active power is the real part of the complex power. It's the power that's actually leaving the circuit or actually being introduced into the circuit by the component. We also have a thing called the reactive power, and the reactive power is the imaginary component of the complex power. And that is the power which doesn't leave the circuit, it's just the energy that bounces around the circuit, being stored in electric fields in capacitors or magnetic fields in inductors, and then coming back out of those fields back into the rest of the circuit sometime later in the cycle. There's only one other thing that I can think of to point out at this point, and that is a consequence of this equation here. Magnitude of I, that's the magnitude of the current, squared divided by 2, is a purely real number. That lot is completely real, which means it works as a scaling factor. It just makes Z bigger, but doesn't change the phase of Z at all. If I have a complex impedance that I plot on an argand diagram, for example, real, imaginary, and supposing Z was there, and that was my Z, then the complex power S would be in the same direction, just a factor of I squared over 2 further out. So maybe S might be somewhere up here. But the key point is that that angle is the same. Z just gets multiplied by a perfectly real quantity to produce S. That changes the magnitude, but not the direction. So the argument, the phase of the complex impedance, is the same as the phase of the complex power. And that's useful to know when you're working out the last thing that you might be asked for, which is the power factor. Because the power factor is the cosine of that angle. It's the phase angle of the complex power, but it's equal to the phase angle of the complex impedance. Right, I think that's all the theory that you need to know to be able to do the problems. So, next video, we'll have a look at some problems.